Welcome students. So now we would like to learn about the practical applications of the investment criteria or investment evaluation criteria, where we would like to calculate from the given information or from the given data, we would like to calculate the different criteria or the different evaluation criteria. So out of the discounted criteria, we will like to calculate, that is the net present value NPV, and then the internal rate of return or the modified internal rate of return. And from the non-discounted criteria, we will like to calculate or learn how to calculate the payback period, and then we will move to the calculation of the discounted payback period also. So this is the process with the help of which we will be learning about that how we can calculate the different values, how we can calculate the net present value of the project or maybe the given investment proposal, how we can calculate the internal rate of return or modified internal rate of return, and how we can say calculate the payback period or the discounted payback period. Sometimes when we go for evaluation of this say investment proposals or the new projects, sometimes they are independent of each other or sometimes they are mutually exclusive. So we have to respond in a way that if the projects are independent and if there is no capital constraint, any amount of the capital can be invested or can be arranged to be invested by the company, because both the projects or all the three projects or four projects may be small, they are small in size, they all are worthwhile and we can arrange the funds for that. So in that case, we have to take the decision on the basis of the NPV or the IRR. If it is NPV, so we will have to say that if the NPV is zero minimum, or if the NPV is positive, then we can take up all the projects, or maybe the projects where the NPV is positive or minimum zero, and the projects where the NPV is negative, so we will not take up those projects. In case of the IRR, if we want to evaluate these investment options on the basis of the internal rate of return or modified internal rate of return, then we will see that the expected rate of return from these projects should be equal to, or you call it as more than the required rate of return. Because we have minimum required rate of return, that is the weighted average cost of capital, that much of the return must come back to us. So if it is available equal to that or more than that, then certainly we can go if the projects are independent of each other, and if the capital is available, if there is no capital constraint, and if the projects can be taken, all the projects would be recommended to be taken up by the firm or by the promoters or the group of entrepreneurs. There could be another situation where the projects are mutually exclusive. Means if you take the one, then you cannot take the other. Right. So you have to take one out of the two or one out of the three because they are mutually exclusive in nature. So again, we have to take a call on the basis of the NPV or the IRR. So the project out of the two is which one is giving the highest or the higher NPV, that would be recommended, and the one who is giving the lower NPV would not be recommended. Or in case of the IRR, if the project which is giving us better IRR will be recommended and giving lesser or the lower IRR will be abandoned or will not be taken up. So that would be the situation. Similarly, when we will go for calculating the payback period, so we will calculate first the raw payback period, non-discounted payback period, and then we will go for applying the discount factor and we will calculate the discounted payback period also. And finally, we would like to arrive at a conclusion that how that investment option will behave or will work out, and how we have to take it up and maybe give the shape. So these are the two problems. First problem is quite simple and straight. Only one wrinkle is that in the second part of this problem, we have to discount the cash flow by applying the varying discount rates. So discount rate will keep on changing every year. First, we are starting with the 12% discount rate first year, and then second year it will become 13, 14, 15, and last year it will go up to 16 years. That's only one wrinkle. But the first part of the this problem is very simple. But still we need to understand that if we have to discount the cash flows, how to apply the discount factor and how to do it. So in this case, we will be learning about that how to practically calculate the net present value or internal rate of return and other criteria if it is required and if the data is available. So we have the two components of this problem. So we will solve first where only the static discount rate at the rate of 14%, we will be discounting the cash flow, and in the second part of this problem, we will be applying the time varying discount rates. And here one important issue I told you in the last class also, that for example, when you are going to evaluate this investment option, you are given the cash flows. right? We are not required to calculate the cash flows. We are given the cash flows and we have to simply evaluate on the basis of these outflows and inflows. So you are given the outflow of 1 million and you are given the subsequent inflows 1 lakh, 2 lakh, 3 lakh, 6 lakh and 3 lakhs again, and we are given the discount factor also, that is 14% in the first part of the problem, and we have to simply discount the cash flow and try to find out the NPV of the project. So let's do it, the first part first, and then we will go to the second part. So in this case, we will have to give the shape to it. So for calculating the NPV of the project, so we will be going for calculating the NPV of the project, NPV of the project at the rate of 14% discount rate, 14% discount rate. So we will start from the very beginning, or maybe from a raw basis. And here, when you want to calculate the NPV of the project on the basis of the given data, so you have to start with, first of all, that we have to start with the cash outflow. First, I will solve this in the equation form, and later on we can move to in the next problem we can move in the tabular form. So in the equation form, we should know from every angle that if we are given the say discount factor table, then how to make use of the values from the table, and if the table value are not given to us, how to calculate the discount factor, means in the denominator how to calculate it, the value of r, because the denominator will be 1 plus r in the first year, 1 plus r power 2 in the second year, subsequently it will keep on increasing up to 1 plus r power n. So in this first part we are trying to learn in the equation form, and then we will be learning in the next problem in the tabular format. So how much is the cash outflow? We are given the cash outflow of 10 lakh rupees, right? This is the total cash outflow 10 lakh rupees, and then plus what is the first cash inflow? This is the first cash inflow of 1 lakh rupees, and what is the discount factor? 14%. So it is 1 plus r. So 1 plus r means, what is the r? 14%. It means it is 0.14. So 1 plus 0.14. So it is 1.14. This is for the first year discounting of the first cash flow. Second cash flow given here is at 200,000 rupees or 2 lakh rupees, and for that you have to discount it 1.14 again, but the power is 2 because it is for the second year. And then you have to take the third year, third cash flow, and third cash flow is given to us is how much? Third cash flow is, let me check here. The third cash flow is given to us is the first one is 1 lakh, 2 lakh, 3 lakh. So first we have taken the 1 lakh, we have taken the 2 lakh, we are going to take the 3 lakh. So when we are going to take the 3 lakh cash flow, right, this is 3 lakh cash flow, and we are going to discount it 1.14 power 3, right? Then plus you take it as next cash flow is how much? After this we are given the bigger cash flow, that is 6 lakhs, and in this you are dividing it by 1.14 power 4, and then last year I think the last cash flow is, that is 3 lakh rupees. This is 3 lakh rupees of the cash inflow, and this is 1.14 power 5, right? So you are given all these cash inflows. This is 1 lakh, 2 lakh, 3 lakh, 6 lakhs and 3 lakhs again. So if we take it up here, this is 1 lakh, 2 lakh, 3, 6 and 3 lakh again here. So we are going to discount this. So this is the same. This is not to be discounted because 1 million or 10 lakh rupees of the investment is required in the zero period, in the current period. So its value is not getting affected because of the time value of money. Only the cash flows which are occurring at the end of the first, second, third, fourth and fifth year, only those have to be discounted, because they are coming at the lag of 1 year, 2 year, 3 year, 4 year and 5 years. So their time value of money concept will be important for us. So if you do this, if you solve this problem, finally, so you will find it out. How would you be solving it? Because this is, you call it as 10 lakhs, right? And this is, we have to discount it. If you discount it, so it comes up as 1.14, and you have to find out the cash flow. If you discount, so value will come, if you divide this 1 lakh by 1.14, so value will come here is the 87,700, right? If you go for the second one, if you discounting 2 lakhs by 1.14 power 2, so value will come here is the 1,53,800, right? And when you will go for this, so you will be taking this 3 lakh would be discounted at 1.14 power 3. So value will come here is 2,02,500 rupees. This is another value, and next value is that 6 lakhs to be divided by 1.14 power 4. So, if you divide this, you will get this value is, that is 3,55,200 rupees. This is the next value. And if you go for the last value, so this value will come up as, that is 1,55,700 rupees, right. So, this is your negative value, right. This is your negative value. All these are the positive values. So, what you have to do is, you have to sum up all these values. All the values are here. We have to sum up these values, and the sum of these values we will have to subtract from the cash outflow. So, 1 million, 10 lakhs is the cash outflow, and over the foreseeable period of 5 years, the cash inflow is 1 lakh, 2 lakh, 3 lakh, 6 lakh and 3 lakhs, and discounted value of this cash flow at the discount rate of 14% is 87,700 plus 153,800 plus 202,500 plus 355,200 and 155,700. So, if you take this, right, if you sum it up, so it will become, this is 1 million, right, this is 1 million plus, you will be taking, if you take the sum of it, the sum will come up as 9,54,900 rupees. And finally, if you find out the difference of this amount, right, so this will come up as 45,000 rupees and 100, and this is negative value. This is in the parenthesis. So, finally, you can say NPV of the project is minus 45,100 rupees, which is a negative value. So, NPV of the project is negative. It is a simple concept, very simple, but we try to know it, that in the equation form, how to calculate it. You could have simply done by this way also, that you take the 1 lakh rupees and you multiply it by the discount rate. And if you see the discount rate in the table given, so you will find it that it is at the 14%, it is 8.77. Similarly, you could have taken this, means by preparing the table, this is a tabular format, and you multiplied it by this. So, this will come up as 7.69, right. But we are doing in the equation form, and finally, you can calculate the present value here. So, we are not doing like this. We are doing with the help of the, or in the form of the equation. So, we could see here that on the one side, you are keeping this 10 lakh rupees as a cash outflow, and then you are calculating the present value of the cash inflow discounted at the rate of 14%. And finally, we found it out that our cash outflow of the project is 10 lakh rupees, 1 million rupees, and the present value of the cash inflow is 9,54,900 rupees. If you see the absolute value without discount, so you will find it is how much? 2, 3, 6, 12 and 15 lakhs. So, the absolute value is 15 lakh rupees. So, if you simply want to calculate the non-discounted say net present value, so you will find out that the project's net present value is positive by 5 lakh rupees or 500,000 rupees. But that is not the correct way. The correct way is that you have to discount the cash flows at the discount factor of 14%, and finally, you have to calculate the discounted value of the cash inflows, cash outflows also, but since we have only one cash outflow of 1 million rupees, and that is in the 0 period, in the construction period, so that will be taken at par, and only the cash inflows occurring at the end of certain years, they will be discounted at the 14%, and when we calculated the net present value, we found it that the net present value of this project is 45,100. This is a negative value, so we will not be able to take up the project, will not be able to take up the venture. Now, we will have to go for the second part, right. If you see this, you have to go for the second part. So, what is the second part given here? First part was what is the NPV of the project if the discount rate is 14% for the entire period, only one discount rate for the entire period. But the second question, or the second part of the same question is what is the NPV of the project if the discount rate is 12% for the first year, for the year 1, and rises every year by 1%, right. So, first year we will take 12%, second year we will take the product of 12 and 13, then we will take the product of 12, 13, 14, and then we will keep on rising it by 1% every year. So, that will be called as a time varying discount rate, and finally, we will have to discount the cash flows. This all this 5 years of the cash flow or cash inflow, we have to discount it not by a static discount rate, but a time varying discount rate, because discount rate will keep on rising. And this is quite natural also, because your required rate of return does not remain the same, because cost of capital keep on changing over the years. Value of money goes down, so cost of capital or the required rate of return keep on changing. So the entrepreneur is not satisfied by a static rate of 12% or 14% or 15%. Rather, he says that first year it is 12%, I am happy with that, but it will keep on rising every year by 1%. So it's a time varying discount rate, and we have to discount the cash flows by taking that into account. So let's try to understand, if there is a time varying discount rate, how to go about it and how to take care of this kind of the situation. So we will go for it. That is, we are going to calculate the NPV, right? NPV of the project, right? NPV of the project. NPV of the project at the time varying discount rate, at time varying, at the time varying discount rate, at the time varying discount rate. We have to go for calculating this time varying discount rate. So discount rate is changing every year. Time varying discount rate So it is the NPV of the project. All other things are remaining the same. The cash inflow is going to remain the same, cash outflow is going to remain the same, only discount factor is going to change. Only discount factor is going to change, so it's going to be time varying. In this case, we'll have to do it again in the equation form. So for calculating of the NPV of the project, right, we will have to take the time varying discount rate and first say the cash outflow is again 10 lakh rupees, right, 1 million rupees. And now we have to take the first cash inflow, and first cash inflow is how much? 1 lakh rupees, 100,000. And you have to discount it at what rate? You are given here is discount rate is simple, that is 12%. So we are going to discount it at 12%, that is 1.12, plus second inflow is how much? Second inflow is 2 lakh rupees or 200,000 rupees. This you have to discount it at some other rate, not simply by say this 12%, 1.12, and it has to be a time varying. So it has to be a product of 1.12 into 1.13. So this is going to be the application of the time varying discount rate, and the third cash flow is how much? 3 lakh rupees or 300,000 rupees. So this we are going to discount at 1.12 first year, second year it was 1.13, and third year it is going to be 1.14. So this way it becomes a time varying discount rate. And in this case, next part is, that is going to be how much? The next cash flow is 6 lakhs, and this is going to be discounted at 1.12 into 1.13 into 1.14 and into 1.15. This way we are going to discount it. This is 6 lakh plus, right, and the last cash flow is 3 lakh rupees. So this is going to be 3 lakh rupees, and this is going to be discounted again a time varying discount rate, and this is 1.12, this is 1.13, and this is 1.14, and this is 1.15, and last one is going to be 1.16, right. This is going to be the process of applying the time varying discount rates and discounting the cash flows. If you discount the cash flows here, so for calculating the NPV of the project, this will become something like that. This is going to be cash outflow 10 lakh rupees, right. This is cash outflow, and this is going to be the first present value of the first inflow of 1 lakh rupees when discounted at 1.12. This comes up as 89286. Then you have to apply the time varying discount rate for discounting the second cash inflow of 2 lakh rupees, and this is going to be how much? 158,028. This is the second present value of the cash flow of the 2 lakh rupees. Third cash flow's value is going to be how much? The third cash flow of 3 lakh rupees. The value is going to be 207,931. This is going to be the third value, and then the next value is going to be, so we have taken 1, 2, 3, 4 values, And fourth value is going to be how much? Fourth value, we are discounting 6 lakh rupees. So this value is going to be 361,620. And then we are going to take the last value, and this is the last value is 155,871. This, when you are discounting it, this is becoming 871. So finally, for calculating the NPV of the project, when you are going to sum it up and you take this. So this is going to be the one part, right? This is going to be one part and this is going to be the one part. So you have to sum up all these discounted cash flows, the present value of the cash inflows which are discounted at the time bearing discount rate at the rate of 1.12 and subsequently rising by 1%. So first was 89,286, second one is 158,028, third one is the present value of 3 lakhs is 207,931, and then is the 6,361,620, and last one is 155 or 155,871. This is the value. If you calculate now the NPV of the project, this comes up as 27,264, and this is again a negative net present value. This is again a negative net present value, the negative value, and for this purpose when we are evaluating the project, so this value is going to be 27,264, and this is going to be a negative value. So negative NPV, that is the 27,264, it is minus. So this is going to be the minus value, this is going to be the negative value, and NPV of the project is negative, or this is in minus. So it means both ways. When we discounted the cash flows at 14% discount rate, then also the NPV was negative. When we are discounting it at the time varying discount rate, again the NPV is negative. So when we see the say previous NPV, it was more negative when it was discounted at 14% discount rate without changing any kind of the discount rate. But when we lower the discount rate in the first year to 12%, and then last year it was 16%, right? Last year it was 16%. So in that case, this final value has become negative, little lesser as compared to the first one, but still is negative. And if you compare this, the cash outflow of the 10 lakh rupees with the present value of the say all the cash inflow available for the say foreseeable period of 5 years. So the difference is going to be negative, that is 27,264. So it means the project is not worthwhile. The project is not worthwhile and we have to abandon the project, we have not to take it up. So this way, it is a very simpler form of calculating the NPV of the project. Only one thing is that we learnt about that how to apply the time varying discount rate. But if the discount rate is static, it's not going to change, then it's very simple that if you are given the information about the cash outflows and cash inflows, so you will have to simply discount it. So for discounting, either you can do it yourself by say taking the discount rate in the denominator of the cash flow, or you can directly multiply it by the discount factor which is available in the present value interest factor tables, easily available everywhere, or you can use Excel. In the Excel all these formulas are inbuilt, and you can simply give the input and maybe give the relevant command. So you can calculate the value, and within no time Excel will tell you that NPV of the project in both ways, whether it is discounted at 14% or it is discounted at time bearing discount rate of 12% and rising by 1% is a negative. So we cannot say undertake this kind of the project proposals. We have to abandon them and we have to not to go for this. So because minimum decision criteria is 0, NPV should be 0. Present value and NPV. So present value can be anything. If you see the present value, even the present value also means present value is when only you are summing up the inflows, the present value of the inflows, and when you are subtracting the from the inflows, present value of inflows, when you are subtracting from the summed up present value of the inflows, the outflows, present value of the outflows, the difference should be minimum 0, that is the acceptance criteria, or more than 0 means the positive NPV. But in the present case, because NPV is negative, so we are going to abandon the proposal. Neither way it is going to be an acceptable proposal and we will have to simply abandon it, we have to reject it, we have not to go ahead with that. So this is the first part, very simple, and we learnt about only one criteria of calculation of NPV when we are given the discount rate and the information about the cash outflow and the cash inflow. Now we will go for the next problem, and then the next problem is little more comprehensive. It's including many say questions to be answered here. So again you are given the cash information about the cash outflow and inflow. In this problem, the information given about the cash outflow is same for both the projects, that is 50 million. The investment requirement for both the projects, there are the two projects, that is project M and project N, right? So in the both the projects, the total cash flow or the investment requirement is 50 million, and we are given the cash inflow and in the absolute form for the period of 4 years. Maybe in this project it could be possible that the foreseeable period was 4 years. So we have to evaluate on the basis of this inflow for the 4 years against this outflow of the 50 millions. So in the first year you are given for the project M 11 millions of inflow, second year 19 millions of the inflow, third year 32 millions of inflow, and fourth year 37 millions of inflow. And for the project N we are given the first year 38 millions of inflow, 22 millions of inflow, 18 millions of inflow, and 10 millions of inflow. And we have to evaluate on the basis of the different investment criteria, different investment evaluation criteria. And the first requirement is we have to calculate the simple payback period for both the projects, right? For both the projects, simple payback period. And then the second case we have to go for calculating the discounted payback period. And third case we have to work out is the, say at the discount rate of 12%, we have to evaluate the projects if they are independent of each other. And in the next case we will have to evaluate the projects if they are mutually exclusive. Independent means when both the projects can be undertaken, there is no shortage of the capital, and if they are worthwhile, if they are giving us the desired internal rate of return or a very good positive NPV, then maybe both the projects, project M and N, can be taken by the firm or by the group of promoters. But in case of the mutually exclusive projects, so only the projects which are giving us the better outcomes in the form of IRR or in the form of the NPV will be taken up. So in this case we will be taking up the mutually exclusive, we will be answering the question about the mutually exclusive projects also. And last question is about the calculating the MIRR, that is the modified internal rate of return. So we are not calculating the simple internal rate of return, but we are calculating or learning about calculating the modified internal rate of return. And on the basis of these 6 questions or 5 questions, we will have to finally conclude whether the project can be undertaken or not, and that too on the basis of the payback period, on the basis of the discounted payback period, on the basis of the NPV when the projects are independent, on the basis of NPV when the projects are mutually exclusive, and on the basis of the modified internal rate of return. So this is a quite comprehensive and interesting problem, and we will discuss this problem in the next class. And there we will be able to have the answer to all the questions. And after solving this problem here, you would be clear with the most of the aspects of the investment evaluation or applying the investment evaluation criteria or a relevant capital budgeting techniques. And finally, we will be able to understand that how we can evaluate the projects in the practical sense if we are given the cash flows, both outflow and inflow, and the requirement of different criteria is also available with us. Till then, thank you very much. I will stop here for this class, and next class we will discuss this problem in detail. Thank you very much.